So my name is Bob Meads, and I am a AR provider area member. I have a product called the IQ Agent. And speaking to some of the excellent points that Carl made, I'm down on the plant floor trying to implement my solution, and the success or failure is going to depend on whether they're able to make money off of what I'm offering them. And a lot of this has to do with data preparation. Our solution to plant floor AR, you have to remember my background's manufacturing. I've been on manufacturing plant floor for 20-something years. I program PLCs, I do SCADA, HMI systems, I've been a production engineer, I've been a quality engineer. So that's where my expertise is. And then when the mobile, when we started getting iPads, I really started seeing that these things are going to be a paradigm shift on the plant floor and really change the way that we did business out on the plant floor. So there are two problems that we focus on, and one is location-based display of relevant data. This talks back to Christine's point about there's lots of data in the enterprise, but none of it's really associated with the objects that it actually represents, and this is an excellent use case for AR on the plant floor. Another thing that we do is use AR to communicate about downtime issues with people who aren't there, because downtime is one of the leading money drains for any manufacturing plant, hundreds of thousands of dollars per minute. AR is also an excellent use case for that, and these solutions require us as a provider to be able to efficiently associate data and resources that to their relevant equipment or process areas out on the plant floor. So that's really where I'm talking from, is this particular experience. So if we're looking out on the plant floor, hopefully we can see everything. All right. So this is kind of boring. All right. Now, back in the 50s and 60s, before Bell Labs invented the transistor, before we had SCADA systems and things like this, we would have dials and gauges, and we would be able to tell everything about this pump or this motor by walking out to it. But when PLCs and computers became predominant, we did something very smart and something very stupid. The smart thing was we started automating this, but the stupid thing was we removed all of the relevant information from the one area where it was useful, which is right at the piece of equipment. We put all of our data about what the pump or the machine was doing, and we put it on a screen in a nice air-conditioned control room. We took all the documents, made them electronic, put them out on a server, and we, so now we have this. All right, so the problem with this is all of the data and resources about this pump are somewhere else. But if I'm going to do something with this pump, then I need to do it right here. So this means that anybody who walks out to this area, to this motor or this pump, has to turn around and leave. They turn their back to the equipment because they don't have the relevant information required to fix it. All right, some people call this a problem. I say it's an opportunity. Okay, so this is a problem that happens in every plant every day. And this is one of the problems that we want to solve with AR. I've had several discussions lately with, the most latest one was with a gentleman on the airplane that I flew over with. And when you ask people about what AR is, they either know what it is or they don't. Some think Star Wars, Star Trek. Some people think head-mounted displays. Some people kind of know what it is. They give the example of the first down line on the TV for what we Americans call football. People can say what AR is. It's a view of the real world that's augmented with computer-generated components that bear some relevance to what we see. They can quote that, but a lot of people don't know what AR actually can do for us out on the plant floor. So what I find is with our customers when we're going out on the plant floor, if I start with technology, if I say, we have an AR solution, I just see their eyes kind of glaze over, and I've lost them. And then I'm in the parking lot wondering what happened. So I usually like to start with a use case and the problems that it does solve, let them see the benefit, and then maybe later they realize what technology that we're looking at. So instead of having this boring pump, we have what we call the point of interest concept, which is a concept that's out there in the industry. If you go into Google, show hotels near me, and it pops up these little red icons. These are called points of interest, and you know that you can mouse over or click these and get some data. So if we add a point of interest, to this pump, I can use that as a marker, a way of locating where I'm at in the plant or what piece of equipment that I'm looking at. And then I can display all this relevant information about it. So I don't need an HMI screen. I don't need to go back to my document repository. I don't need to go look up my vendor contacts because I have all this information here, and that's outstanding. One thing that AR does very well is allow us to associate relevant information, data, and resources with entities like this. All right? This is a great use case. It's not the only use case. But as it turns out for my customers, and this is where my passion comes from, you threw me. All right, so just this functionality is a great benefit to the plant floor. All right, so I have no problem of showing this to people and them realizing the benefit. Then we have to have a discussion because the plants are very big. There's a lot of data. There's a lot of equipment, and we have to first look at where all this different data might come from. So if we're getting live data, this typically is coming from the automation system. How many of you guys know what PLCs, microphones? I'm sorry. All right. So PLCs and SCADA systems, are any of you familiar with these? All right, this is where we're going to get this automation data. Typically it's in the form of tags. So I have to go talk to these systems in order to get this information. This means this is some of the data that we're going to have to prepare. Production databases, SQL Server, Oracle, these are a couple of examples. But I have to be able to get to these to maybe get some of this production type information. Also document management. If we're pulling out schedules or resources or schematics, then I might have to go to an electronic document repository or some other repository, so I have to make a link to this. And then also we have preventative maintenance, asset management, production reporting. These are generally, some type of database. So I have a lot of different things that I now have to access, and this is the data that we have to go after. When we're deploying this type of application, any AR type of application that offers this type of functionality, the customer and the vendor have to work together in order to connect data with assets. I make the point here that the customer is the expert on their own plant floor. They know their equipment, they know their data, they know they know this stuff. Somebody there knows it. I'm not going to walk into your plant and know that. I might recognize a pump, I might recognize a motor, but I'm going to need your help. My expertise, the AR vendor's expertise, is going to be able to take that data once it has been prepared and provide the association, provide the display, provide the AR that allows you to use this data, to use this AR. So the customer is always going to play a key role in preparing the data so that I can give you an effective solution so that we can all have ROI, because that's really what it's about. Is it can be flashy and it can be nice, but if it's not worth your money, if it's not saving you money, if it's not increasing efficiency, then it just doesn't matter. So on the customer's part, and some of these points merge nicely with what Carl had said in his presentation. First, we have to define the process areas and the problems that we want to solve by the AR solution. Where am I going to use it? What line? And this is going to start to tell us what equipment and processes are going to be targeted for the solution. We typically don't go in and say we're going to do the entire plant. We're just going to knock it out. Usually we're going to start with one line. It's going to be representative of all the different types of data that we're going to access. We're going to shake all the bugs out of it. We're going to get it working. And then as we roll that out to the rest of the plant, most of the dragons have already been slain. So once we define that process area and the problems, we need to define the target users of the solution, and this is going to help us further refine how they're going to use it and what data providers in the plant that we are going to use. If it's maintenance, then a lot of the data providers are going to be documentation systems, maintenance systems, preventative maintenance, and these types of systems. If they're engineers, then we may be pulling stuff from the automation system to get live data. If it's QA, there's a lot of different use cases, and obviously these systems can be targeted to more than one type of user. But once we've defined the user and where they're using it, this is going to define the use cases and the data providers. So where am I going to have to get data? Then we take a closer look at how the user will interact with the system and what they're actually going to do. And this should give us everything we need in order to define the data and resources that have to be prepared by the system, how they are displayed. And these steps are typically taken by the customer and by the vendor. Typically it's led by the vendor. You sit down and have a conference and you hash all this stuff out. So this is kind of how we identify the data providers. So then once we have this information, we can take this and we start, we take the prepared data that is coming from the customer and we go out and we do our implementation. And for any AR system that is giving this type of functionality where we're defining assets and showing assets and the relevant data, we have the definition of the equipment and processes, and we may assign it some type of marker, QR codes. It could be a low energy Bluetooth, it could be a beacon, it could be RFID, it could be object recognition, or it could be dead reckoning. So we have to have some way to identify, and we have to go out and assign those. Typically points of interest out in a plant for any solution, they can be a piece of equipment, but they can also be something that is ambiguous. It could be the output of a production line, it could be a work cell, it could be a warehouse shelf for that matter. Anything that we can characterize with the data that the customer has can be one of these points of interest that then we can supply data using an AR solution. Once we have our points of interest out in the plant, then we need to assign our prepared data and resources that are relevant to each point of interest. And this is where we take the data that has been prepared either by the customer or by a joint collaboration between the customer and the provider, and we assign those. And this is really the meat. This is where Carl's talking about the need to automate this. Once we have this done, then we can use our AR app, and it's going to identify the marker using whatever technology, QR scanning, Bluetooth, or whatever. And then the data provider or the AR app is going to use its own data providers, go out and pull all this information that's been prepared, and we're going to show it on the screen. It sounds pretty easy, right? Okay. So why prepare the data? Why look at the data? Well, if you have a little bit of data, maybe you don't need to. We can just kind of bang it out in a couple of days and have some coffee. Here's an actual use case. The customers that typically go for this type of AR solution have a lot of automation. They have a lot of data. They have a lot of people running around on the plant floor. So primarily the people that are attracted to this type of application, automotive vendors, people making automobiles, chemical, pharmaceutical, food, and beverage. Not limited to that, but also utilities. So for this particular use case, it's an automotive vendor, and they have a really cool plant. If you've never been in an automotive plant, they have all these different assembly lines, and the further you go forward, the more complete the car is. So they'll have an assembly line for each individual piece of the car, and then they all kind of come together. Well, a typical plant with our customer is 8,000 points of interest. That's a lot. Each point of interest might have 7 or 8 connections to a piece of data. All right, so 56,000 links that I have to make. So the manual time, if we just wanted to go throw some interns at this, is going to be about 60 man days, and they're probably going to make some mistakes. You can figure on 3 to 5% of that is wrong. That's a lot of time, that's a lot of money, and the customers end up going to have to pay for that. However, if we can prepare the data and if we can get it into some type of standard interface so that we can automate populating our AR apps database, we can save a lot of time. Computers are very good at that. But computers, the thing is, it's garbage in, garbage out. So if you don't have structured data, if you don't have data that makes sense, if I can't programmatically look at it and know where it's supposed to go, then that's not going to work. So by importing the customer's prepared data, typically we accomplish this in about 8 man days. So that's pretty good, and that's repeatable. We can push this out to all the different plants. All right, so that's why we do this. Effective. So when we talk about automating data connections and preparing our data, basically it boils down to how well we can define the connection between plant floor assets and the relevant data and resources in our AR solutions database. My solution has to know that's the incoming bank motor, and then it has to go pull up that relevant information. Therefore, your asset data must be structured in such a way that its relevance to a piece of equipment or a process is obvious, programmatically speaking. All right, not from a user reading it, but from a computer program reading it. So the goal is to be able to identify related assets by a data's provider, name, and how it's stored. I should be able to look at all that and say that goes to that pump exactly right there. If I can get to that, then my data is prepared. So typically we can use standards. I say Excel because everybody seems to know Excel, ODBC, which is database. These are not the only standards. If we have prepared data, we can use standards to automatically parse the data and populate our AR solutions database rather than have it manually entered. This is what Carl was saying about automating these data connections and scalability. So from the automation system, the SCADA system, HMI, and PLC, typically we refer to these entities as tags. Each PLC might control part of the process. Typically, this data is visualized by a SCADA or an HMI system, and sometimes they use intuitive naming conventions, and sometimes they don't. A lot of big providers, they'll have OEMs coming from Europe to the U.S., and they've been using these systems for years and years and years. The naming convention might be in German or it might be in Swedish. Most of us over there, aren't, especially our maintenance guys, probably not fluent in those languages. So basically, it is possible, since we know the PLC and we know the SCADA system and we know the point that that tag is relevant to, if they have used some type of same naming convention for the PLC, for the connection, then I can identify that point all the way down. And typically, these types of software systems have a way to export this out into Excel, which gives us a gateway into a database, and then we can use it. So typically I'll talk to the engineers, I'll look at, hopefully they've used some type of naming convention, we might have to do some mapping. So typically here's an HMI screen, a SCADA screen, and we're looking at a motor and we see information. This would be information in the form of tags. In the configuration of this particular HMI, it's a Siemens HMI, we can see these tags and we can see that the naming convention has been used. We know that it comes from Press System A7. We know what PLC it comes from. Each tag has a prefix with the name of the entity on it and what it represents, and I know my data type. So from this, I can programmatically infer where it goes from, and so I can export this directly into Microsoft Excel, push it out into our SQL Server database for our AR, and I'm done, as long as the data is prepared. So this is one quick way that we can do this. Now, that being said, if you started out with a good naming convention, this is easy. If you didn't, it's a little difficult. Preparing data from electronic document management systems, it's kind of the same thing. It's going to boil down to how you house the data, how you structure, where the data is stored, and what the naming conventions are used. So server, folder, and file naming conventions, which will allow for programmatic identification, plant systems, elements, resources, and the universal resource locator, the URL to that document. That makes sense, all right? Within documents, one of the things that we found is, depending on how you structure the data, you can use bookmarks to further make that data atomic and go out and identify it. And I'll show you an example of that. Another thing that we found is some of these documents tend to be big, so when you go out and scan them, it may take 30 or 40 seconds to pull it up. If it's a big document, this can be based on your wireless network. So we've often had to go in and kind of chop those up into meaningful areas of the process, but keeping them small in order to display them. SharePoint and most electronic document management systems will export directly into Excel or other standard formats. So if we have our naming convention done well, we can do this. So here we have Microsoft SharePoint. We can actually export that directly into Excel. It will give us our document names. It'll give us our path to this, and we can use this directly in our database. So what I'll show you very quickly is if we look at, say, a representative document, Make sure that this shows up here. Okay. If we look at a representative document, all right, you can see that we've used some bookmarks here, and we can look at and find different POIs and find different links that are relevant for this. So I can run an application that will actually go out, and I can pull all the documents out of that folder. All right, it'll list the documents and start processing the files. And basically, because the data has been prepared and because the naming convention is correct, then I can write some scripts, in this case a C# application, to run through every one of these documents, taking note of the folder that it's in, the name of the document, the bookmarks of the document, and the page numbers of the document. And what I'm going to end up with when this is run is basically an Excel sheet of all these POIs that I can just push right into our database. But it's going to depend on if you used, some type of naming convention in order to do this. So now that we're done, I can go out and look at this sheet. All right. And so basically I've created, probably at least a couple of thousand points of interest off of these documents that I can now load into my AR system database. So I haven't had to do my manual configuration. So I'll typically go back to the customer. We'll decide on how they're going to organize this stuff so that our applications can run it, and then we can just start churning this stuff out. So in summary, AR solutions which associate relevant data with plant assets are a very huge benefit to efficiency and productivity. This has been proven. This is a great solution. Implementation of AR solutions often require the customer to, we require the cooperation of the customer in order to prepare the data to get it into a form that we can automate this data preparation. Data from the plant automation system, documentation, reporting systems must be prepared so that its relevance to a given plant floor asset is obvious. Once you do that, I can get it into a standard format. We can push it into our AR solution database, and then most of the hard work is done. So well-prepared data allows vendors to use these standard interfaces to automate the population of the AR solution. Saves a lot of time, reduces a lot of errors. All right, that's it. All right.